Swayam Prabha. Digital India. Educated India.
Welcome to Module I, Lecture 2. In this lecture, we shall discuss about road safety engineering and crash data. In lecture I.1, we discussed about the global safety scenario, road safety scenario globally and also within India. Then what are the causes of road crashes, common risk factors of road crashes and fatalities, what are the causes of road crashes as per the available data in India, what are the factors affecting human characteristics, the driver vehicle road systems, the physical and psychological or environmental characteristics that influence the human characteristics or which are important as a part of human characteristics as well in the context of human characteristics, and the other factors human which are also influencing human characteristics. Now, with that background, first today we shall focus on the road safety engineering aspect and the crash data then. Road safety engineering is a competence and experience in the investigation and analysis of crash locations where the crashes are happening and or potential crash locations. So, it could be a location where as per the data available with the authority, we know that significant number of crashes are happening, or it has the potential to be a high crash location in the future based on certain identified deficiencies, and the design of effective remedial engineering treatment. So, competence and experience in the investigation and analysis of crash locations or potential crash locations, and then the design of effective remedial treatment. All the components are included. It is a multidisciplinary subject and the elements may include crash investigation, crash reduction, crash prevention, all may be included. And understand that both prevention and cure should be inherent element of an overall road safety management system. Cure is one part, cure means you have a problem which is already identified. So, we know the problem. So, we have to offer a medicine for that, cure it. Also the prevention, not only the cure, but also the prevention. So, prevention and cure both should be inherent element of an overall road safety management system. What are the different ways to deal with the road safety issues? We said about the various road safety issues in the previous lecture, but what are the different ways to deal with the road safety issues through the eyes of road safety engineering? There are broadly two approaches, proactive approaches, reactive approaches. What is reactive, what is proactive? Of course, the meaning can be, you can understand probably the meaning, but let me tell you, reactive means the problems are happening, crashes are happening, fatalities are happening, the recorded data showing that such kind of problems are occurring more frequently than what is expected, more statistically higher rate of occurrence at certain locations than other locations, then you know that there is a problem, it is a problematic location or there is some issue. So, now you try to address that problem You try to find out why it is so, what is really causing it, and what kind of medicines or countermeasures I can do to solve it. So, that is basically the reactive approach. That means, it may include one way the descriptive analysis of the police reported crash data. So, you have the data available normally in every country. The quality may vary one country to another country, one even state to another state, or one region to another region, but some data is available, and even in a good, if the data recording system is very good, database is good, you may have quite exhaustive data. So, you know that in the past how accidents have occurred. It may not be location specific, as I said only in while I was trying to describe reactive approaches. It may not be only specific to locations, but you know the causes, you know the data about road, about traffic, about violation of rules if any, and weather condition and everything, and you know what kind of crashes happen and how the fatalities happen because of those. So, you have quite good amount of data is available, and you do some kind of analysis of that data to understand the relations, the interrelations, the role of different factors, and then use the knowledge to make policies, make measures. That is one aspect, which is also reactive, because based on the accident data we are doing something. The second could be crash prediction models. The other way you can develop crash prediction models. So, we can know that thing. So, descriptive analysis is one part, then modeling you can do, you can develop crash prediction model. Again, your reasons are known, variables are known, y is known, the outcome, be type of crash, or whether it is fatal, whether it is severe injury, or whether it is property damage. That way, the type of crash, whether it is head on collision, what is side crash, or what kind of rear end collision, that way also you can think. So, basically you have exhaustive database which is available with you, and you can actually try to develop using those databases, you can try to develop crash prediction models or even the crash severity model. I said both way, type of crash, head on collision, rear end collision, side crash, or also the severity, whether it is minor injury, whether it is major injury, property damage only, or even the fatality. Right. So, all sorts of descriptive analysis, modeling, understanding the relationships, understanding the role of each factor which is contributing, how each independent variable or attribute is contributing to the overall y or the outcome. The outcome could be type of crash, severity of crash, number of crash, okay, overall crash, it could be anything, what analysis you do, and or cross classify the data and develop different descriptive analysis, all sorts of things you can do, but all based on available accident data. That is what is the reactive approach. I react to accidents or crashes. Crashes are happening, fatalities are happening, I am reacting to that. So, I am looking at the database, and also location specific I can do. I can even find out the high crash locations and then do some specific investigation to find out the causes. All are actually reactive approach. So, accident investigation also is reactive approach. That way, location specific I can do investigation, because the data overall shows that at some places more accidents are happening, statistically more accidents are happening as compared to other locations. So, there must be something wrong with those locations. So, we try to investigate, try to find out, and then take corrective action. So, a variety of things, a variety of analysis, so many ways, descriptive analysis, crash prediction model, crash severity model, accident investigations you can do location specific, identifying the high crash location, all a number of things can be done, but these are all proactive, a reactive approach using the accident data. Second is proactive approach. We do not wait for the accident data, we do not wait for the accidents to occur, and we do not wait also for the accident data. If it is available, you are using it somewhere, that is a different thing, but predominantly we are not waiting for the accidents to occur. Proactive, before it occurs, we are taking the measures, right. Or you can say the reactive approaches could be, once the problem is known, then you are analyzing, trying to understand why it is happening. The proactive approaches is something like a health checkup, right. Before it happens also, you are trying to understand that what actions I can take in advance to avoid that problem in a way. So, road safety audit comes under that. Safe system approach, it is known, globally known, globally accepted. So, you take that safe system approach, assessing road users behavior, perception, and then trying to see that how they are going to react and how they behave, and therefore, given context what could be the issues. Simulation based studies, I do not wait for the crash to occur, but any future proposed system I can simulate in a realistic manner to see if there are certain issues, certain challenges, certain problems. Work out with the surrogate safety measures, it need not be the crash, but directly, but I can work with surrogate safety measures. So, for example, post encroachment time, PET, or even the number of conflicts in an intersection. Suppose if I am able to reduce the number of conflicts in an intersection, obviously the overall safety level is expected to be better. So, surrogate measures, not directly the crash data, but some other measures which you can quantify relatively easily from the field or from videographic data, or you can do some kind of field measurements, and then you can compare that my system is now this and I am making this improvement even without waiting for the accidents or crashes to occur, and then therefore, I am able to reduce or improve this performance, expect the performance to be even better. So, lot of things you are able to do without waiting for the accidents to occur. That is the proactive approach. So, both proactive and reactive approaches are there as a part of or the ways you can handle the road safety issues. As I have mentioned already, the few slides are there. Reactive approaches associated with identification of locations experiencing safety problem, that is screening, we call it as screening. Identifying locations which are experiencing safety problems, how to do the screening. So, it includes screening, then the problem definition, that is I am referring to the diagnosis part of it. So, screening, diagnosis, and then I have to treat also. You cannot say only you have a problem, you have to tell the medicine. So, the identification and implementation of countermeasures, that is the cure. So, reactive approaches are associated with screening, diagnosis and cure, all the three stages. There are certain downsides of these reactive approaches, as I have already told, but let me just quickly go through it once again. Solely depend on crash data, you are depending too much on the crash data, and understand that crash data itself is a big issue, especially in low and medium income countries. The systematic data may not be available, the right data may not be available in right format or required format, all the information that are relevant may not be recorded. Okay. all sorts of issues are there. So, you are depending so much on the crash data, where availability of the correct and complete crash data itself is a big challenge in LMICs. Second, require the identification of high crash location before improvement plans. Suppose you want to treat something, you want to first identify the high crash locations, identify the specific intersections or specific locations along a highway where the statistically more crashes or more fatalities are happening as compared to other locations. And overall, the treatment following these reactive approaches might be costly, more expensive in every sense. First of all, your accidents have occurred. So, people have suffered, deaths have happened, injury has happened, property damage has happened. So, already the loss has happened, so much loss, and also the treatment later on is also expensive. Why? Because you have already built the system and already open to traffic. After opening to traffic, you are experiencing crashes, and therefore, you are trying to identify what are the reasons, what are the problems, and trying to take action. So, you are essentially any interventions, if at all you can do. Some cases you may not be able to do all the interventions. So, your solution space will often get very restricted, because you cannot probably rebuild the entire thing. You have issues, face issues like the land acquisition related issues also, but even if you are able to do something, you are actually interfering with the system. You are trying to redo or partially even, or doing some intervention on a system which is already built and open to traffic. So, the anything you want to do is obviously going to be more expensive. On the other hand, the proactive approaches associated with prevention of the safety problem, how I can prevent, right, before the accident occur. So, associated with the prevention of safety problems before they manifest themselves in the form of a pattern of crash occurrence. Obviously, as compared to the reactive approaches, the proactive approaches will have definite advantages, which may include first the crash prevention. It is not necessary for crashes to occur before crash prevention measures are taken. You do not wait for the crash to happen or people to get killed to before you take the action, right. You look at the potential safety and accident or crash or crash potential, right. You do not wait for the crash to happen, but you try to assess the crash potential based on available scientific knowledge, evidences and expertise, available expertise. And obviously, this will have lower cost, because many cases you will take the interventions before you have actually implemented and executed the project, right. So, you have not built an intersections and then getting accidents more or crashes and then trying to see what is wrong. Even before you build, probably at the design stage itself, you can audit and you can probably see that what is wrong, and there is an issue of side distance, and then based on the land use, this kind of pedestrian movement requirements will be there heavily. So, I need to provide it when I am widening the roads or so, and then you build it in the make appropriate changes in the design itself, and the construction is done accordingly. So, you are actually saving cost. One way saving life, saving the damage, because you are not waiting for the accidents to occur. The other way, the implementation part is also very easy. It is less expensive as compared to the previous approach, where you have already built the system and open to traffic. Effective road safety management program should exercise an optimal balance between reactive and proactive strategies. You should have both. Normally, everything you cannot really assess even proactive using the proactive approach. There could be restrictions, there are limitations. So, it is also necessary to work how we build good database, because many things are possible not only location specific treatment, but many understanding and insights can be developed based on the actual accident data, right, or actual crash data. So, the actual data database, crash database, very sound crash database with all related information, accurate database, that has got an immense value also, right. So many other things can be done, that is important. Also at the same time, you need to follow the proactive approaches, because not everywhere you will wait for the things to happen and people to get killed or people to get injured and so many crashes to occur before you wake up and start doing some intervention. So, a balance of optimal balance of both reactive and proactive strategies. Now, going to the crash data, which is I said very important for the especially the reactive approaches. Why we need crash data? Because road authorities need to have crash data to reduce crashes and severity of crashes. I must know where the crashes are happening. That is the first thing any authority would be interested, because that is the reality, not a speculation or not an assessment or anything, but that is the real data. The real data always will have a big strength. I must know whatever I have done, is it actually reducing the number of crashes? Maybe you have done an intervention. How effective is that intervention? Is it working properly? Is it really giving me the result? I must know, I must have the crash data. The accuracy of investigation, analysis and effective treatment, whatever you want to do at crash location, relies on the availability of comprehensive data and quality of the data. How comprehensive is the database and what is the quality of the data? Do I have all the informations available? Road related, vehicle related, weather related, driver related, all informations I have available, and do I have the really correct information? So, it has got a value. Everywhere you cannot use only, you cannot depend only on the proactive approaches, you can also cannot depend only on the reactive approaches, and a combination or an optimal balance is important, and therefore, the crash data is also very important, because your any output will be as good as your data, because if the data is wrong, data is incomplete, the outcome also will, you will have less confidence on the outcome, right, whatever is the outcome is coming based on the analysis. Now, good crash data is the necessity. If you have good crash data, so many things can be possible. What are the characteristics of good crash data? When we can say that, okay, my database is good, first I should be able to, some points I have said, not all. Crash locations I should be able to pinpoint. I know where the, at what, which location the crash has happened. I should be able to pinpoint that location, right. In traditional sense, you will say it happened somewhere near this. Near this, it could be anywhere, right. You do not know exactly where it happened. So, it may be difficult, but if I am using a system where the GPS coordinate exactly is getting located, it tells me right at this location it happened, right. The sequence of event in a crash are properly mentioned, how occurrence, how it led to this one. Maybe it started raining and then it was night time, and then this was the type of vehicle, and the whole thing you should be able to get that. Then the contributing factors in a crash or group of crashes are mentioned. I should be able to identify that all those data are available. The contributing factors in a crash or a group of crashes are mentioned, and all relevant information regarding a crash are included. I have the route geometric features, I have the other external factors, crash location, type of vehicle, time of the day, weather condition, everything is there, because many cases, many times you will find the data is available, but you have not, you do not have the complete data, it is somewhat incomplete. Now, if we have the good crash data, as I said, what are the characteristics? Some predominant characteristics, but if we have those type of data, then what we can do? Lot of things. Common risk factor across a number of crashes can be identified, not only location specific, but you can see it a little bigger sense that what are the common risk factors across a number of crashes. Is the speeding coming always, or is the poor road geometry, is the weather condition, whatever it is, it can be identified. The cost of consequences of a single crash, all crashes at one location or several crashes with common factors can also be identified, because you have the data saying that because of crash or crashes what exactly happened. Fatality, severe injury, property damage, maybe multiple people also died in a crash. So, the cost consequence of a single crash, all crashes at one location or several crashes with common factors can be identified. Similarly, several crash sites can be identified and you can also rank them. Every take measure so many junctions or mid block, every kilometer or half a kilometer small sections, you can say where the more things are happening. So, you can rank them, right, you can rank them and then you can pick up one by one and then try to see what is happening, or locations which are having higher crashes than expected. The crash data source, where from we can get the crash data? You can get it from primary data source, you can also get it from secondary data source, some of the things complementary, right, because so many data you can get from the primary source. Say for example, road authority, they will have the crash data, police crash report form, so many things, police FIR, they are writing so many things, crash database sometimes could be there. In many of the states in India, also including the state of West Bengal, we have very good database. Yeah, it has improved a lot, right. So, the statewide database also, the nationwide database also will be available. Nowadays, even the nationwide also there is lot of effort to develop and upgrade the database, right. Lot of things are happening in truly positive directions, right. We have problems, we are number one in terms of fatality all over the world, but lot of good things are also happening. So, I am sure the future will change, future will be able to address our concerns effectively. Secondary data source may include hospital record. Fatality did not happen immediately, but maybe after that, after hospitalization. So, hospital record can tell you many things. Insurance companies, because insurance claims are linked. Interview with road user, local knowledge, many other source could be there. So, these are all secondary source which also sometimes give you lot of valuable and important information. Coming to crash data collection system, the traditional methods what is being followed in India, majority of the cases or what we used to follow earlier case also, the police reported FIR. The crash data recorded in police FIR with at least one eyewitness report, and the summary is prepared by the police stations and finally aggregated data sent to MORTH on annual basis. That used to be the condition. So, you can see how the FIR looks like. So, we used to go and take the copy of FIR, go through it and then extract information, create a digital database. Many times it was only hard copy, handwritten things that were available. So, used to go to the police station, collect those FIR copies, come back to the lab and then note down the things. Sometimes they will not allow you to also take a copy. So, you have to sit there and record the information what you want, but that is the traditional way. Then ministry came out with a format, MORTH, Ministry of Road Transport and Highway, Government of India. It came out with a format 17 items broadly. There are many, but I have broadly grouped them like 17 items. All these are to be, so some kind of uniformity and consistency all over the country, right. It is MORTH format you use for collecting data. They include like accidents by month of the year, and then area or time, when in which month it happened, then which area, urban, rural, at what time, classification of road, whether it is NH, national highway, state highway, MDR, other district road, village road, type of location. There are 13 items. So, you can say that what is the location, how you describe the location, type of junction and traffic control, weather condition, vehicle types, what age of vehicle, what is the nature of accident, what are the causes of accidents, whether there is a fault of driver of motor vehicle, what is the type of victim, right, motorcycle, bicycle user or a pedestrian, what is the age, what is the gender, the details of drivers, the vehicle details also, type of person, skilled, road condition, road feature, quite comprehensive and satisfactory. So, the next attempt was uniform format. People were not recording every item in FIR or so. Now, you have accident data information recording procedure, a format, use that, get all the data in the prescribed format. Okay. So, you have IRC codes also, which tells you also related to this, right. I am not going into details of it. The IRC codes are also available. Then slowly the shift is happening. We have smartphone, we have mobiles and smartphone and GPS things are available. So, many small simple equipments are also coming in the market. So, the modern methods aim data acquisition at source through mobile device. In fact, some of the initiatives were also taken by IIT Kharagpur, my colleagues who developed such kind of things, that using a smartphone you can actually. So, if you go to a location, coordinates are available, GPS will tell you where exactly it is, and then many information you can feed there itself, right. So, data acquisition at source through mobile device. So, you can do the visualization and such kind of things you can get. So, you can more reliable data you can get, and it will ask you to fill up every input. So, you can do that. And so, automatic feeding of data using GeoSMS or data transfer to develop 4 database. One is accident related, then road related, vehicle related, person related, including driver, pedestrians, accused, victim. So, these are the broad components. So, using query to extract relevant information and fill up the 17 item format of MORTH, what I said here, right. So, there are 17 items. So, this ensures one time data entry and minimum post processing time. So, then what is happening now is something in the same direction, further proceeding further is use of IRAD, Integrated Road Accident Database. It is the Government of India has recently launched the Central Accident Database Management Systems. 6 states are initially included in the project, now the number has increased also. The IRAD mobile applications what is developed actually will enable police personnel to enter details about a road accidents along with photos, videos, and following which a unique ID will be created for the accident, and therefore, engineers from PWD or the other local body receive an alert, and everybody from their part they input the data. So, ultimately you get a very comprehensive data, right. You get alerted, all concerns will get alerted, and then everybody they fill up their portion and visit the site, and finally, you have a comprehensive database. You can see lot of more information, lot of information about the IRAD is also available in the public domain. So, simply just open up the website in your Google, you can type IRAD, you can say IIT Madras also has got a lot of contribution, they developed this thing. Indian government of India is quite actively working, trying to implement this, and different states are also coming and under this IRAD system. So, eventually every state has to come into this system probably, and you will find that these are all very positive news, and because all this will help the country to have a very good and reliable database in the future, right. So, that is what is necessary. So, what we discussed today is what is road safety engineering and what are the different ways to deal with the road safety issues, proactive, reactive, what are the advantages and disadvantages, and then finally saying that a balanced combination of both proactive and reactive strategies, and then the importance of the crash data, why we need it, what should be the general characteristics of the crash data, what are the things I should be able to do and what I should be able to achieve if to say that it is a good crash data, then what are the sources, and then the data collection method, traditional to modern methods, and even the development of IRADs, the contribution of IIT Madras and the Indian government's initiative, and then more and more states are coming and using the same platform. The homogeneity, people using similar platform or same platform, in so many ways it is very advantageous, right. And what is important, the national level, all across the country is such a big country, length and breadth wise, so many states, so many different geographical regions. If we all following a systematic and unified approach and contributing to the development of very reliable, complete and comprehensive database, accident database at the national level, that can add a lot and can help the country to address the concerns related to road safety in an effective and efficient manner. So, with this I close this lecture. Thank you so much.